Hello everybody, and welcome back to Space Engine. Oh boy, it's been like, what, about a month since I last did a video? Or a Space Engine video anyways. And that's entirely my fault, but I'm back at it. I noticed my YouTube revenues have actually dropped this month. So, yeah, Space Engine is good. People like Space Engine. I need to do more Space Engine. And Species. And, other such things. Anyways, ooh, wrong one. Let's just get right into this, shall we? I have one recommendation from last episode to go to, so we are going to go there. Apparently, it's a Terra in an extremely interesting location. So, let's go. I always love hearing new things. Okay, you can go. Oh, wait. Anyways. Alright. How interesting is this location? It appears to be in a cluster. A very dense cluster, mind you. Let's look at the host star, get some information on what's going on here. There we go. Right. So it's the 6th planet out. This is a very hot star. This is a very dense cluster we're in, too. I believe it's this one. And all of its various moons. Huh. Right then. Let's look at some... Go away. Go... Oh, nah. Is it F4? No! No! There we go. Alright. Okay. Yeah, it's been a while. Oh dear God. Okay, where are we? Here we are. Get some info on this here planet. It is biogenic, which means that it's, well, it's local. It wasn't brought here from anything. Let's check out the atmosphere. It's mostly carbon dioxide, bit of oxygen, water, sulfur dioxide, nitrogen, and helium. It's not bad. That's a very carbon-rich atmosphere. It's almost Mars-like. Well, Mars' atmosphere is mostly carbon dioxide, yeah. So that's actually interesting. That is interesting. What is its density? Huh. Well, alright. It's thicker than Mars anyways. Whatever. Right then, let's look. Oh! Well, I didn't notice that. Let's check something. I'm seeing an issue here. It's not... Oh, there we go. There's a random star there. What's this? This is our planet here. And all of its various moons. However, there's a black hole around here somewhere. Right. I think the black hole isn't... Yeah, no, it's not in the part of the system, but the system orbits the black hole. That is a massive black hole. Look at that accretion disk. Let's... Ooh. Well. Alright, let's get right up close to this. And while I fiddle with this, what's new in the world? Actually, a lot of funny stuff has happened. Politically, I suppose. People don't like when I talk about that stuff, so I don't know. However, there was some indication that Alex Jones is in fact just a performance artist, and everything he says is, like, made up. And, I'm pretty sure I called that a little while ago, so I'm rather pleased to hear that I may have been right all along. So that's really funny. Bill O'Reilly getting fired was also funny, but also not unexpected. And that's pretty much it. I don't know. Actually, speaking of black holes, we may get our first picture of a black hole's event horizon soon. What's that? Those stars stuck by the accretion disks? Let's find out. Oh no, they're way on the other side. See, it's light bending around the black hole for you. But yeah, a recent effort to try to get a picture of a black hole's accretion disk by basically linking up a whole bunch of antennas, radio telescopes, there we go, in series around the world to make a basically a radio telescope with a virtual aperture the size of the Earth. And they got all the information, and now they're compiling it, so we may actually be able to get our very first look at a black hole's event horizon. Because currently all we've ever really seen is the accretion disk and like X-ray and all that. So this is actually really exciting. I'm looking forward to that. We should get the pictures sometime later this year, like once all is done being processed, because the raw data is all just raw data. It isn't actually a picture right now. So that's really cool. I love stuff like that. What was that? My desk settling. What else is new in the world? The current commander of the space station beat the record for longest stay by an American in space. That's exciting. And she was actually also the first female commander of the space station during one of her other stays, so that's also pretty cool. Alright, what did I do? Let's just go back home, because I'm scared. Flump. Actually, I have a better idea. Let's do something interesting. Saturn. Because Cassini is starting its death spiral into Saturn's atmosphere. It's actually going to burn up in the atmosphere on my birthday, which is September 15th of this year. That's kind of depressing, because I love Cassini, so the fact that it's going to be dead on my birthday is, kind of a depressing gift. But it's also going to be a lot of interesting data, so I'm looking forward to that. It's during one of its recent passes, it managed to fly down in this gap here between the rings and the planet, which hasn't been done before by a spacecraft. Earlier in its mission, it did go, I think it went through the Cassini divide, which is this gap. I'm pretty sure it did that, actually. But anyway, so it's getting closer and closer to the planet, and we're getting a lot of really good pictures and data from Saturn, because everyone loves Saturn. I like Saturn. Some of its moons. Also, speaking of Saturn, since I'm here, no, I want to do Saturn. We're going to go to Enceladus, because I also love Enceladus. Because Enceladus is one of those ice moons that everyone loves, and it also has, it has cryovolcanoes. In the southern area, this lag is really, in kind of the southern area, around these ridges called the tiger stripes, you get these plumes of water jets, and why? It's just Fraps. I need to get a better program. Fraps is terrible, because it lags everything to hell. Anyway, so you get these plumes of water coming out of the jets, or out of the planet's crust, and Cassini's actually sampled these water jets. Now, when Cassini was first built, nobody knew there were water jets coming out of Enceladus, so they didn't really put much effort into instrumentation for that. However, Cassini does have spectroscopy equipment on board to sample. They were thinking dust and other stuff in the environment around Saturn, but after discovering these plumes, I think Cassini actually discovered them while it was doing a fly pass. They decided to use these instruments to actually sample some of the water coming out of the jets, and they found that it contained, it was mostly water, contained some ammonia and other carbon compounds, as well as molecular oxygen, which was very interesting. And this actually leads to some people thinking that maybe we should spend more time going to Enceladus instead of Europa to look for life, because we know more about Enceladus than we do Europa in terms of its internal environment, and we have more evidence to indicate that Enceladus could harbor life than we do Europa. However, Europa's closer, and now with the the confirmed discovery of water jets coming out of Europa, they want to investigate Europa further, because again, it's also closer, so it's easier to get to, you know, in the grand scheme of things. So I think actually the Europa, or no, NASA's Europa Clipper mission, I'm pretty sure has gotten the go-ahead and is going to be launched sometime in 2020. I'm not entirely sure. And there's also a couple ideas for a mission to Ganymede and a mission to look at all the ice moons in Jupiter by the Russians and the Europeans, respectively. So that's also interesting, and I hope more comes of that. I really hope we do more work around Saturn, specifically to my favorite location, which you probably all know because I talk about it frequently, Titan. I like Titan. It's a fascinating moon. And actually, there was this idea for a quote-unquote rover idea to go to Titan that basically involves, you land a probe on the surface, and it has basically quadcopter rotors. And after it lands, it does its science, and then it chooses a new destination, and it quadcopters away and lands somewhere else, and just basically rinse and repeat. And since Titan has a very thick atmosphere with very low gravity, respectively, I guess compared to Earth, you don't actually need a lot of energy to fly, because like the atmosphere is a little thicker than Earth's, but the gravity is closer to the moon. So you could theoretically a human with could strap large wings to their arms and glide and maybe even fly by flapping their arms and stuff. And that just sounds really fun. So the idea of having a quadcopter that can hop around the surface of Titan is actually a really grand idea, because it can basically cover hundreds of kilometers of terrain and go pretty much all over an entire hemisphere of the moon over the course of a few years, as opposed to a rover which can only cover 40 square kilometers in the same amount of time. So I really hope that mission gets the go-ahead. It's buying for the funding for the 2019 choice of missions for I think the Discovery class missions, the lower end, or it's basically small cheap missions. But there's also another mission in that buying for funding to Venus Explorer, which I'm also kind of interested in, and then a couple of moon missions, unmanned missions, and I think an asteroid mission. But since we already have OSIRIS-REx going out to an asteroid, and the Japanese Hayabusa 2 going out to an asteroid, I don't think we really need another asteroid mission right now, and we should probably focus on other things. So I'm hoping that either the Venus one or the Titan one, preferably the Titan one, because it's far more interesting to me than Venus, although I do love Venus, and I do think we need to explore it more. What we need is a better way to get around the solar system. We really do. One idea I've looked at are something called a torch drive. The term was coined by Robert Heinlein, author of Starship Troopers, one of my favorite books and my top favorite movie. Very different, but I love them. Anyways, and basically it's an idea where you don't have to do Hoffman transfers. If you have a mission, god damn this lag. If you have an engine that can basically burn for a very long time and produce high thrust and high delta V, you can basically just go in a straight line from point to point. I think they're called Bochistrodrome trajectories. I can never pronounce it. If you want to know more about them, Scott Manley did a video a while ago talking about them, and it's very comprehensive, and it's far more literate than I am, because again, I stutter and I trip over myself, and although everything's organized in my head, it really is not when it comes out. So I'm not really going to get into the details about it, but basically all I have to know is it's a concept for an engine where you can burn it for a long, long time, and basically go point to point. And theoretically, such an engine, if you had one that had reasonably high thrust, you could get to Jupiter in a week, or actually no, Jupiter in about 2 weeks, because it's a week of acceleration. Actually, maybe about 3 weeks. It's a week of acceleration, then a week of coasting, and then another week of deceleration. You can get to Mars in a week. That's right, because you accelerate for 2 weeks. No. You accelerate for a few days, continuously, non-stop, until you reach the the midpoint, and then the ship flips around and then burns it continuously until it ends up just sliding right into orbit. And I've actually played around with it in KSP, and it actually does work. It's kind of hilarious. As long as you get the timing right, if you can literally just go point to point, from planet to planet and anywhere, without having to do Hoffman transfers. You can literally just aim at the target and go. So that would be really cool. However, we don't have such an engine that exists currently. There are some ideas that might work. There's an idea for like a fusion engine that basically uses deuterium pellets, and it fuses them and makes a large amount of energy and exhaust thrust, and that could theoretically do it. It's very complex though. There's another idea by Dr. Robert Zubrin. It's basically a nuclear salt engine. This is Mars. And it basically uses water that has a 20% solution of uranium tetrabromide, I think. And you have to store it in these like carbide, beryllium carbide or something. Not beryllium. These tubes of neutron absorbent material, and you inject little bits of the water into the reaction chamber, and the uranium in the water goes critical and basically explodes, and then is ejected out the back. And this engine basically operates like an Orion drive that uses nuclear explosions, but instead of like bang, 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 it's one continuous explosion, non-stop, out the back of your engine, and you can get theoretically really high thrust with really high, or not really high, but pretty damn good fuel efficiency. Unfortunately, with such an engine, if you have a fuel leak, you die. If too much fuel goes into the reaction chamber, you die. And if the engine gets plugged, you die. So that's kind of an issue, because again, it's basically it operates on uranium going critical. So if you have a large amounts of uranium suffering a criticality experiment, or a criticality event, you die. And that's just a luminous supergiant. And that's just an unfortunate case. Ooh, it's a binary. Antares A. I think I've been here before. I mean in game, not in real life. If I had actually been in Antares, that means that I don't have to talk about torch drives, and I can talk about like superluminal drives. Okay, go away. There we go. Ah, it's so pretty. Let's go to the blue one. It's probably prettier. So yeah, that's a really great idea. I would love for one of those ideas to come to fruition, because oh god, it's really bright. Because currently, in order to launch missions at the planet, we have to wait on launch windows. Basically, the times when the planets are lined up properly, that we can send a mission there with the best fuel economy and the shortest amount of time. With Mars, okay, go away. No. With Mars, a launch window opens about every 2 years. With Saturn, I think it's every like, what is it, like 4, or it's like 12 years, something like that. It's really dumb, and I don't like it. And basically, the further out the planets, the slower they move, the longer the launch windows. So if we had the ability to produce a torch drive, launch windows would only be used for basically just time, but they wouldn't really be necessary. Like for example, you could get to Mars anytime you want, as long as Mars wasn't, as long as there's a line of sight. So they can't, like, if the sun's in between you, you can't do that. You have to wait for the line of sight. But you don't have to wait for the launch window. Oh. Whereas with oh, that was life. But you could, well, like the time it takes is a bit. Sorry, ideas are organized in my head and they fall apart and become like a deluge coming out. Depending on where Mars is, the travel time would be higher or lower, but you could still get there faster than we currently can. So, for example, it would probably be best to wait for when Mars and Earth are at their closest, just to reduce travel time. But you don't technically have to wait until it's close. You can basically just wait until the line of sight. This lag is really irritating. And with the outer planets, basically, you could go to Saturn every year, like once a year, and it would take like 4 or 5 weeks to get out to Saturn. So basically a month and a half to get out to Saturn with a torch drive of, well, I guess pretty high power, as opposed to like 6 years doing a Hoffman transfer with like gravity assists. So here's hoping that one day, because that would be grand, Like grand as in, fantastic, not grand as in big. Although it could be big. I don't know. Ooh. R and F do this? Oh. I'm learning how to fly things again. Alright. So that's really exciting, but there isn't too much research into those, to my knowledge. I kind of work on them, but I'm not a reputable source, nor am I, gonna get anywhere with it probably, because I have, no resources. On that note, my program, my space program, we're thinking of doing a balloon launch in, well, actually, literally a weather balloon. We're going to see if we can detect gamma flashes in active thunderstorms. But we're still waiting to hear back from Transport Canada on that one, whether or not we're allowed to do that or not. Either way, we still want to fly a balloon and gather some actual data. And we currently have the idea for a gamma collector and maybe or a gamma detector and maybe a aerosol particulate sense counter. But if you guys have ideas for any other kind of science instrument that'd be interesting to have in a weather balloon going to the stratosphere, leave in the comments, because I'm actually looking for ideas. No living things, just no. I'm looking for science payloads, so no living things. Anyways, thank you all for watching. I hope you enjoyed. This was more of a science talky episode, which is what people like, and I'm gonna do this more often. So I hope you all enjoyed, and space.